Okay, that should be recording now. And just, yeah, it's recording. And what I want to do is start with chapter 3. This week we have chapters 3, 4, and 9. And each one are really different, but it's probably best we do them in order. They are pretty different and probably don't depend on each other, but there's a reason the author put them in that order. So chapter 3, I think, is one of the easiest to understand. And since it's a totally online class, you don't have to memorize anything. You're always taking tests or doing homework with your book beside you, with notes beside you. So we're just going to try to take what's in there and consolidate it into some reasonable amount of notes and that you could apply to homework. And we'll try to do a few homework things or homework type problems.
8:30 to 9:30.
Oh, I had to go until 10.
The chapter talks about how to analyze financial statements. And the biggest way they're analyzed. Oh, hi.
Hi.
I looked away and didn't realize somebody joined us. Hi, Mary.
Hello, sorry I'm a little late.
No, not a problem. I was running late. Everything is just not on schedule today. One of those kind of days. We're just getting into chapter 3. Hopefully you can see an Excel spreadsheet, which doesn't have much on it right now.
I can. It says chapter 3. Got it.
And we're starting to talk about what's in chapter 3 and what are the important things.
Okay.
So chapters 1 and 2, we try to teach you what are financial statements, and now we're looking at how do you analyze them? How do you decide if a company's doing well or not doing well, or what does all this stuff mean? And one of the ways to do it is to perform ratios. And it sounds real complicated, but if you go to page 58 in the book, there are 13 ratios listed. Sometimes it's hard to type and talk to. Your final paper, you're supposed to take that company and analyze it. And I always summarize it as like your friend comes to you and says, I'm thinking about investing in this company. What do you think? And imagine you went back and did a whole analysis on the company and came back to your friend and said, I don't think so. And here's why. Or, yes, I totally agree with you. You should invest in that company. And here's why. So chapter 3 is great for helping you analyze the company. So this is really relevant to your final paper. The ratios are broken into 4 subcategories of profitability, asset utilization, liquidity, and debt utilization. They like to make fancy words, but the profitability ones are trying to help you decide if the company is making a profit. You don't really want to invest in a company that hasn't been profitable, isn't currently profitable, and doesn't look like it will be in the future. Sometimes there's companies that have had a bad past, but they're turning the corner and they're doing better, or they've got a bright future ahead of them. So I can't say that just because they're not currently profitable, you shouldn't invest in them. But these ratios will help you decide some things. There's 3 that fit in the profitability, and those are profit margin, again, dealing with profit, return on assets, and return on equity. I managed to type over that one. Okay, so the formulas for each of these are conveniently highlighted in the book. So these first 3 are talked about in more detail on pages 60 and 61. You'll see the formulas are given. Profit margin's pretty easy. Let's see, where can I put this? You know what, I think we'll just shove all this stuff over a little bit, give ourselves some room. put this here and yeah. Then talk about profit margin is net income divided by sales. All it means is if you make $1 of sales, how much of it do you keep is net income? If you keep 5 cents, then you make a 5% profit margin. So when in the book, when they're trying to introduce it, they give you on page 59 the income statement and the balance sheet of a hypothetical company. So when they teach you the ratio, they're also showing you the financial statement and saying, if we need to compute profit margin for this pretend company, how would we do it? And so they would go to the income statement to get both of these things, net income and sales. Net income is the bottom line of the income statement, $200,000. And sales at the very top is $4 million. When they divide them profit by the sales, they get, I'm letting them do it for us, 5%. Making sense?
Yeah.
Return on assets is pretty simple also. It again is net income because they consider that their return on their investment. How much profit did I get because I have sales or assets or whatever the return is we're looking for. So this time we're doing a division, but this time it's not sales on the bottom, it's assets. And the total assets are found on the balance sheet, and they are listed as $1.6 million. And still the same profit or net income on top. So that's 12.5%. And return on equity is very similar. It's net income divided by stockholders' equity. So all these profit ones are really focused on how much net income did we make in relation to this other number. And when you're doing this to evaluate a company, I would take the time to look at several years. I'll write down what they had for this one, 20%. But while we do this, they gave you the information that we're using to make this 5%, 12.5% for 2013. Supposedly, this hypothetical company, these are the financial statements for them for 2013. When you try and do this for your company that you're writing your paper on, it would be a good idea to get multiple years of financial statements. And a lot of times when you download, let's say 2014's annual report, they will probably have 1 or 2 prior years also in there. So maybe you download 2014, but it shows you net income from 2012, 13, and 14, and all the other numbers. So you'll get a chance by downloading 2 or 3 to get many years worth of data. And then you can put them side by side and say, well, in 2013, it was 5%. What was it in 14? What was it in 12? How's the trend going? So maybe at the end of your paper, you can make a little trend chart that shows, here's the profit margin, and there's this nice little graph of it going up and up and up. That visually tells a nice story of my company's getting more and more profitable. Or even that it's got steady profits and the line's real flat, but it's not going down. On page 60, you'll also notice that they put the industry average. They went out and figured out whatever industry this company's in, how do other companies that do what we do, do they have a bigger profit margin than us? Do we have more profit than them? So as you do in your paper, look at some competitors and do the same analysis with the competitors, at least for a few key things. So you can always say how your company's doing over time and how it's doing compared to others. So as you go through chapter 3, not trying to make this too glossed over, but I think you get the idea. On page 63, there's 5 more ratios. And then as you go on to the next page, the rest of them are on page 64. It works the same way. There's the ratio, the formula on how to compute it. They work it through for that sample company and actually show you the math and how they got to the answer they got to. It will be good to have the formulas on your notes, have them handy. It's a lot easier than having to thumb back through the book to find that particular formula if you just have all 13 in one convenient place. Also, know what the formula means. I always use the example of my kids when the twins were born, they were born premature. They were neonatal, and there was all these machines hooked to them. And I remember just being inundated with information from the nurses that I didn't completely understand about this machine's numbers going up and that one going down, and I didn't know if that was a good news or bad news. And of course, I'm sure it was postpartum emotions too. But it finally came down to I needed to know, is up good? You know, am I praying that number goes up on that machine or down? And if I could get it down to that little bit of information, I can process it a little better. So you need to understand that as you look at the answers you get in computing the ratio, what do they mean? And if they're going up over the years, is that a good thing? Is going up good? Most of the time it is. Most of the ratios are meant to going up is good, but not all of them. You have one called the debt ratio, how much debt you have. You don't want to see that one go up. So just kind of as you're reading, see if you get an understanding of what the ratio tells the reader and how to interpret any trends that you're seeing. That sound manageable?
It does.
Okay. Just thumbing through the chapter to see if there's really anything else in there. The ratios are by far the important part of the chapter. So I would not worry about some of these things at the very end of it. On page 67, they start an area called the impact of inflation on financial analysis. Kind of interesting if you just want to learn, but it's beyond the scope of anything you need to know for the course. And that pretty much continues on through the end of the chapter. So from that point on, I would say it's not real relevant to reading. Great if you go ahead and read it. It's not going to hurt you, but just understand that if you're getting a little lost in it, it's not stuff you need to know. You really need to focus in this chapter of understanding the 13 ratios. Sound good?
Sounds good.
Okay. Just make some reasonable labels here on the tabs. And let's talk about chapter 4. Chapter 4 gets into the concept of the time value of, forecasting. I'm jumping to chapter 9. I always forget. Chapter 4 gets into forecasting, what I call budgeting. Chapters 1 and 2, and even really 3, we learn to make financial statements. Financial statements are always backward looking. You write them at the end of the year or even the early part of the next year, like right now in January. A lot of companies are pulling together all their numbers that happened in 2015. And pretty soon they'll be publishing financial statements reporting how the company did in 2015. So they're always looking back and reporting on the past, which is great, but companies also have to budget and forecast forward. If you're a manufacturer, you need to be thinking, how many do we need to make next year? Well, that depends on how many we plan on selling. So there's all these little parts of the puzzle that have to come together to get a plan. And that's what page 97 has a chart that's trying to show you the thought process that happens in budgeting and forecasting. It all starts with the sales budget or forecast. I'm going to use those words interchangeably. So if I use budget and they call it projection or forecast, I mean the same thing. Some high up people in the company get together and decide what they think next year's sales are going to look like. The marketing and the advertising people probably have a say in it. Production, everybody comes together and they come up with some number. From that, then they can turn that into production. I'm going to go a little farther with my story just as an example so you can get an overview, but this is probably going to incorporate more things than you're going to need to know in your homework. So let's say that they figure in next year, in January, we hope to sell 1,000 products. Well, then production needs to think about that and say, well, if you need to sell 1,000 in January, I better have 1,000 waiting for you to be able to sell. I got to keep you supplied with that number of products. And since that's only an estimate, I don't think I would give them just exactly 1,000 to sell. It would be wonderful if the estimates were a little low and we had enough customers to sell 1,100 products. So production often figures out what they need to cover the sales, how much cushion they want to have left over, and they also look at what they already have in stock. Why make it if there's already 300 products waiting in the warehouse? Then they don't need to turn around and make another 1,000 to cover the sales. They might scale that back some because of what's on hand. So the production department needs to consider what they already have on hand. Okay? So instead of giving you a mathematical example, that's kind of what they're going to do. And you're going to see the actual math of that in the chapter, where they'll try to figure out if they want this much left over and they start with this much and they got to cover 1,000 units of sales, how many products do they have to make? Excuse me, I've got to beep. My husband accidentally set the alarm for nighttime. We had a good laugh over that one when it went off. I thought he'd reset it. Okay, so from the production then, imagine that finally all those calculations are done and production realizes they need to make 1,100 products in January. Then the schedulers can start figuring out how many shifts that needs to be so they can figure out people. So then a labor budget can be figured out. This is beyond what you're going to be doing, but I just kind of want to give the big picture. Let's call it raw materials. Production then has to figure out what they need to have for raw materials. If they're going to make that many products, then how many raw materials do they need? If it takes 6 2x4s to make the insides of a couch and they're going to make 1,000 couches, then they've got to figure, okay, do I have 6,000 2x4s or do I need to buy some? And I don't want to cut it too close, so I want to cushion it a little. So the raw materials budget usually comes back to some decision like this. What do I already have on hand? What do I need for what I'm going to make? And what do I want to have left over? So they have to go through that whole thought process too. So the production leads to a lot of other budgets. But finally, after they figured out sales and production, they can make estimated financial statements. So they can say, if everything goes as planned, next year's income statement should look like this. Next year's balance sheet should be about this. And they can really start to forecast how they think the upcoming period's going to be. And if the results aren't what they want, then they can go back and tweak the sales budget, which will cause a ripple effect through everything else. Maybe change the sales price so that profits look a little better, or shave some costs and do some cutbacks. So that's where we're going, but it's going to start really simple. Page 98 talks about making the sales budget. And the example says that this company makes 2 products, wheels and casters. And they've had their meeting, decided how many they plan on selling and what they plan to sell them for. So in the first table, it just says, for the upcoming period, we plan on selling 1,000 wheels and 2,000 casters at these 2 prices. So that can bring in a total of $100,000 in sales. So they've made their sales budget. It's nothing fancier than that. If the company only makes 1 product, then it's really simple. It goes on from there showing you how they would decide how many products to produce. So table 4-3 on the next page actually walks through the logic of, if we're going to sell 1,000 wheels, how many do we have to make? They go through the math and figure out they need to make 1,015 wheels and 2,020 casters. What we're going to look at in the homework problem number is 4, is looking at a few that involve probability. Again, making a sales budget. So if you turn with me to problem 4.4, and then the one below it, 4.5, page 113. Problem 5 talks about Bronco truck, and they are trying to figure out what they think their sales are going to be. And nobody can agree, or at least it's all a matter of if. If the economy's great, if the year is good, we might have this. If the year's bad, well, I think the sales are going to be about this. They call them outcomes A, B, and C. I call them good year, bad year, and middle of the road year. So outcome A is not so great. It says that we could sell 350 products at $21 a piece if the year goes like that, the way they expect. So let's talk about this being, I'm going to turn the chart around a little and say units and price. That dollar amounts. And the units are 350 at $21 a piece. So if they have a kind of poor year, let's label that a little bit better and just say A is a bad year. They'd have $7,350 worth of sales. If the year's a little better than they thought, kind of a middle of the road year, they plan on selling 600 at $30. And if it's a really great year, their estimate is they could sell as much as 1,050 products for $35. Okay with me so far?
Yeah.
Just to kind of estimates based on what's going to happen. Then they give them a probability, the chance of it happening. These can be written as percentages or decimals. It just happens that they give them as decimals. So the first one, it says there's a 40% chance. that that is what's going to happen. So they had a 40% chance they're going to have a bad year. They have a 10% chance of having a middle of the road year and a 50% chance of having that really great year. So what do we do with those percentages? We actually multiply them. So we say that we have a 40% chance of having a $7,350 year. So I just take those and multiply them by each other. You do not have to do it in Excel. I just hope that you're seeing, and this is a good venue to put it up there. You don't want me handwriting, trust me. My handwriting is not wonderful, so this is legible. Make sense?
Mm-hmm.
Okay, so do that for each one, how much the year was going to be by the percentage, and then you just add them up. And that gives you the final. Yeah, I can hit a few buttons with my fingers when I want. Projected sales. So that's the best guess, kind of averaging all of them together, of what the sales are going to be next year. So instead of 3 possible opportunities, they kind of smushed them all together and came up with one number. It's not going to be exact, and that won't be next year's sales, but it's a ballpark. So you have a problem identical to this. If you look at the one above it, problem 4 is your homework. If you want, you can steal this right out of here, retype in the numbers as they give them to you, type in the percentages here, and it will calculate for you. So you've got the format. You can lift it off of here. You can even right-click down here where it says Chapter 4, and it will give you a chance to move or copy. You can create a copy. Just make sure you hit the check mark and click OK, and you've created a copy of this sheet to use over and over again. Or you can download one copy of this file I send you and then download another one with another name. So come up with the sales budget. Can be as simple as the one we saw in the book, or can be as confusing as the one we did. But hopefully won't be terribly confusing. Let's see. Another one that you have to do is number 7. And so we are going to look at number 6, because again, 6 is very much like 7. So we're going to do one that really is close to your homework. I'm making the notes on the screen so people reading this later know what we're doing. Question 6 is at the bottom of page 113, and it is very similar to question 7, which is part of your homework. And instead of multiple possible outcomes, good year, bad year, middle of the road year, they are saying, let's start with what our sales were last year and just plan on a little increase and a few things happening, and that will help us figure out this upcoming year. So it tells you last year, the company had sales of 3,500 products at a price of $75 each. So if I do the math on that, last year the sales were $262,500. And last year, or this year, they expect that the number of products to go up by 30%. Probably, for people reading this, might be nice if we go in here and go. Be careful on these. If you're not great at percentages, a lot of people will compute 30% and say next year's sales are 30% of this year. In other words, much smaller than this year. We're looking for next year's sales. to be bigger than 3,500. Because we know they're going to be more than last year, 30% bigger than last year. So when you do the math, you actually want to go 3,500 times 130%. To work it out a little slower, 3,500, 30% of that is 1,050 increase. So then you'd have to go 3,500 plus 1,050 equals 4,550. So either way, you can do it this way, or you can multiply by 130%. But just keep in mind that because it said it wanted to increase them, that your answer needs to come out higher than last year. Now they said the price, however, because the reason they're going to sell. Oh, okay. The other problem has one increase and decrease. This one says that the price is going to go up by 40%. So we need to raise the price from $75 to something more. There's a price increase. So we're going to follow the same pattern. 75 times 140%. So the new price is going to be $105 a unit. And for some reason, they think we can still sell a bunch of them, more than last year. There you go. And so from last year's sales being 262,000, this year the sales are going to be a lot bigger. The one last step they're going to throw at you is that some of these things are going to get returned. This year, returned merchandise is going to represent 8%. So 8% of these are going to come back to us as returned. So I need to figure out what 8% is. So I'm going to take that times 8% and then subtract it and say, okay, well, how much did I really sell? So I really sold 439, or I'm planning to sell 439,530. Make sense?
Yep.
Okay. So two different ways to possibly come up with that sales budget. One with multiple possibilities of what might happen, and the other is just last year, but it's going to go up a little, it's going to go down a little in price, and so using all that to budget out. And problem 7 follows this pattern almost identical. Numbers are different, percentages a little different, but the idea is exactly the same. After talking about the sales budget and the production budget, kind of walking through the different budgets and how they all feed into the financial statements, they talk on page 101 about the ending inventory. And it kind of takes me back up to what we were talking about before. When we talked about the company deciding how much they were going to sell, then someone has to go through this thought process of how much they already have in stock, how many more they need to make, and what do they want to have left over at the end of January. That would be called their ending inventory, what they're going to have left at the end of January. And they're looking at some of that on page 101. Where we're going to go with that is a little different discussion. But we're still looking at the inventory. Let's find some new space here. And products are either made by a company, like a manufacturer, in the example we used above, and sometimes we're a merchandiser. We just buy ready-made products, slap a price tag on them, and sell them to customers. But either one of those companies is going to have an inventory of products waiting to be sold, whether they were products they made themselves or bought from somebody else in order to sell. And generally, the inventory, even though of the same product, can have different costs. So I'm going to pretend we're a merchandiser. It just makes the story a little easier. So at January 1, in inventory, we're going to say we had a quantity of 100 products that when we bought them, they were $5 a piece. Then we restocked in February and bought some more, and they were 200 units that we purchased that day, and the price had gone up to $5.10, which is probably a common scenario. They restock and the supplier charges a little bit more. So let's say this happens a couple more times during the year, and now the price is $5.25. And I'm totally making numbers up just to give you a hypothetical story. And unfortunately, I'm going to make the price keep going up. And there. I'm going to multiply these out to get a value on them. 100 at $5. And then carry that through and come up with a grand total. So at the end of our period of time, we got somebody joining us. Ellen, are you able to hear me? Let's let her get settled in and maybe set things up. So now we have our story. During the year, we started with some inventory and we continued to build. I'm going to change that to January. During the year, we sell some. During the year, we sell another 450 products. Which 450 did we sell? There's nothing in here that tells us. And most of the time, if these products are generic and they don't expire, or they're not like milk that you would want to make sure the old stuff gets sold first, most of the time it doesn't matter. But it matters on the books. On the accounting records, what you choose to show as sold can make a big difference in your profit. So the company needs to make an assumption about the sales order. You can choose FIFO or LIFO or an average. And we're just going to talk about LIFO and FIFO. Shrink this down a little bit so I can get a little bit more visible on the screen. It doesn't actually have to be the order in which the products are sold. Usually they just pick a method and say, let's just for accounting records assume. So if this company assumes that the 450 sold were in the order of FIFO, FIFO means first in or the first out. LIFO, obviously the opposite, last in or the first out. FIFO is probably the way most of us think about it. We would say the 450 that were sold were probably the old stuff in January, probably these February things, and a good chunk of the ones from June. So FIFO would have the January 100 sold, the February 200, and June 150 of those. That would give them all 450. And if you carried the prices over, yeah, well. I know what's happening here. There we go. And multiplied it. They would say that out of the ones that are sold, that much was sold. They would say that's the cost of the goods sold. Right? Okay with that? Figuring out which ones were sold? Then to figure ending inventory, so if these were the ones that were sold, there'd be 100 of the June ones left, the 325 from September, and all the December ones. Or we could just take 5,301 and subtract the 2,307.50, and that would give us the amount in ending inventory. So almost $3,000 would be what they'd consider in ending inventory. I'm going to be a pain, and I'm going to ask you to try to do LIFO. LIFO is going to say this was sold and work upwards until they get all 450, and then they'll say the rest are still here. So I want you to try to come up with cost of goods sold and ending inventory for LIFO. And I'll give you a few minutes, and let's see if we can get Ellen talking to us. Ellen, are you able to hear us okay? I think she logged out to log back in, hopefully. Oh, sorry. I realized I scrolled out of your visual range. There you go.
I have my number. Do you want it?
Okay, yeah. I just kind of hated to rush anybody.
Okay. I have 2,600.
For which one? The cost of the goods that were sold or the ones that are still left?
The cost of the goods that were sold.
And Mary still working on it, or?
That was me,
Oh,
Mary.
I'm sorry. I looked it
Okay.
up. Amy doing okay?
I had 2,731.50 for cost of goods.
Okay. So let's work on it together and see if we can figure it out. First, let's deal with the ones that were sold. So they would be the December at 100 products, September $325, and then we just need just a little bit more out of June. 25 out of June.
I don't have.
They're in
Oh,
the,
I think I knew what I did. I realized I took 50 out of it instead of 25.
real easy to do. Okay, and we'll carry the multiplication over. $2,600 for cost of goods sold. And then we would just take the 5301 and minus out our 2,600 and get our 2701.
Mm-hmm.
There we go. For ending inventory. Conquerable? That is your homework from chapter 4. You've got the two problems, reading numbers already, 4 and 7 that match the two we did up above about the sales budgets. And then you've got problem 12 at the bottom, which is a LIFO problem. It gives you information like we set up here and asks you only to do LIFO. If you're with your book, take a look at page 114 where problem 12 is. My one word of caution is the title over beside the number in the very left-hand margin, for me, says cost of goods sold dash, and mine says FIFO. But then when you read the problem, it says please do LIFO. So I think it's a typo. I don't know if they've corrected it in the newer versions of the book. So it may not be an issue, but I don't want you to get tripped up by one thing saying one and one saying the other. You are to do LIFO. We are really flying through this. Chapter 9 is all about the time value of money. And it's a concept that is taught in some other classes. So sometimes I run into students that have already learned it and some that haven't. And it can be confusing. We're going to find the easiest way to conquer it. So if you'll turn with me to chapter 9. As you are looking through chapter 9, you will see that it is full of mathematical equations. They also show you how to use Excel to do these calculations, and I'm going to show you an even easier way. So what they're trying to show us is how much money you'll have in a bank account. It's used for problems like that, that you want to figure out how much interest will pile up on something, how much will be in your bank account if you just leave the money there, and so on. Probably the easiest way to learn it is to look at some of the problems. Go with me to page 287. Problem 2 is one of the simplest and straightforward and easiest to understand. Oh, sorry, not problem 2. I want to find a future value one, sorry. Problem 5. It's on the next page. Not that problem 2 is a problem, it's just easier to understand if we start with problem 5. You're going to put $9,000 in the bank and just not touch it and they tell you in Part A that you're going to leave it there for 2 years in an account that's going to give you 9% interest. And they just want you to do the math to figure out how much will be there. Okay, it's possible and really not too hard with only 2 years to do it manually. We could take 9,000, times it by 9%, we get $810 the first year. We'd put $810 in the account, and then we'd have $9,810 to leave in there 1 more year. We'd compute 9% of that, add it in, and we'd know the final total. But we don't need to do that. We can actually do something much easier. And so I'm going to take you and show you a website with a calculator that's awesome. I will send the links out in the announcement, but I also send the Excel worksheet in. So let me share my screen. There we go. And hopefully you're able to see that. We're going to go to bankrate.com. Oh, sorry. I have too many calculators that I use. Dinky Town. It's a ridiculous name. .com. It comes up with a whole bunch of financial calculators. Comes right to that window. You can use it to calculate mortgages and loans and so on. We're going to go to finance or financial calculators. You pick finance and then basic financial calculator. And I will try to send the link right to this location instead of having to navigate through the menus. You're given what looks like a calculator. You've got the face of the calculator, and you just use your mouse or your pointer and click each button. And it's, for whatever reason, hard to see up here, but that's your calculator window showing you what you're inputting. So you just click the numbers and input them. I'm going to clear it out. I'll explain how all the buttons work, but if you forget what I say, down below tells you what every button is for and how to use it. I'm going to remind you a lot to clear, because you don't want to find something stored in memory. These buttons down here help us do the time value of money. PV is present value, what you have right now. So we have 9,000, so I'm going to type 9,000. It shows up here. I touch PV, and I drop 9,000 into that button. So I've told the calculator I'm putting $9,000 in the bank. Another thing that it needs to know is what's the interest rate. I don't need to take 9% and turn it into a decimal. I can just type 9 and hit the interest rate, and it turns it into 9%. And how many years? That's what the N is, number of years or number of periods. 2, so I'll push 2 and then the N. I'm not making payments. That would be as if I was depositing a certain amount every year for so many years. I'm not doing any of that. I'm not going to make any additional payments into this account. And I want to know what I'll have in the future. What is my future value in this account? So I just say compute future value. And there you go. That's how much money you'll have. So let's do a couple more of these just to get an idea. Let's do letter C, which is many more years. You're going to leave this money a lot longer. Letter C says you're going to leave it 25 years at 14% interest. So the first thing I do is grab a type of 0, and then I touch every button. That drops 0 into every one of those spots. It's just safer than accidentally leaving a number in a box and it changing your calculation. So now I'm going to input the 9,000 again into how much money I'm starting with. And it doesn't matter if I do interest rate or number of years first. compute future value. So that $9,000 will grow to $238,000 if I just leave it alone for 25 years at this really awesome interest rate. Okay? Feel like conquerable? Finding future values isn't too bad. Letter D confuses the story a little. As if the interest is compounded semi-annually. That means instead of $9,000 being in the bank and you waiting a whole year before the bank computes some interest and drops it in the account and grows your balance, and then you wait another year, you're actually only going to wait 6 months for the interest to plop in and then for the interest to earn on interest. So how do you deal with that in this calculator? Since it really doesn't work with different periods of time. You can't say quarterly or monthly. What you do is you change the number of periods to 50. Because we're going to have 50 half-year periods of time over the life of this investment. We're putting $9,000 in the bank for 25 years, but 25 years is 50 half-year periods of time. But if the N's going to represent the number of half-year periods, then the interest rate has to represent the number of, or the amount of interest they will earn in that half a year. So that needs to change to 7%. Make sense? You got to cut the interest rate down. So let's look at, make a note, semi-annual interest compounding. I'm adding to our Excel spreadsheet, so the notes that we just talked about. Years times 2 and interest divided by 2. Okay. And if it was quarterly, you would have just turned the 25 into 100, multiplied it by 4, but divided the interest rate into fourths of the rate. And you can put in fractional, like 6.5 interest rate or something. Compute future value, and the future value does change. It's $265,000 now. Not a huge difference, but enough that it makes a substantial difference if they can compound the interest semi-annually or annually. Okay, that's future or computing future value. Now let's go back to question 2, which flips the story. Question 2 says, I want to have $7,900 in my account in 10 years. I have an 11% account. How much do I need to put in today in order to have that much in 10 years? So that helps a lot if they're budgeting for some big expenditure. How much money do they need to set aside now that will make sure it'll have enough when they want it? So I'm going to zero out everything just to be safe. I'm going to put in the amount of money I want, $7,900, and that's not my present amount. That's what I want in the future. I'm going to wait 10 years at 11% interest. So the years of the interest plop in just like they did in the other one. And now what I want to know is the present value. So it's very, very similar. Just got to keep track of whether you're looking for the present value or whether you're looking for the future value. Some of your other story problems will involve payments. That's the one thing we haven't talked about so far. You're either going to be finding future value or present value in all of these. But you're going to vary on whether you're just putting in an amount of money in the account and leaving it, or whether you're going to put in so much each year for the next so many years. Take a look at number 11. page 288. It says that you're going to save or put away $8,500 every year. And you're going to leave it there for 12 years. You're going to do that for 12 years at 10% interest. How much will you have? Well, putting $8,500 in a bank account every single year, that's going to pile up even if there wasn't interest. But then the fact that that's going to grow interest is even going to make it larger. So all we've got to do is put our $8,500 in as our payment, because that's what we're paying into this account. And put in how many years we're going to do it. So the number of years is 12. And the interest rate is 10%. And we want to know how much we'll have in the future. So we'll compute future value. And if we did 12 years of $8,500 and let it grow interest, we'd have over $180,000. Going too fast? Going too slow?
Good.
Okay. Okay, occasionally there'll be ones where they tell you the payments and you need to find the present value. So let's look at one like that. They have a couple of stories. Number 6 and 7 give you choices. Should you do this or that? It's kind of like the lottery choices of you can take a lump sum or you can take payments over the next so many years. In question 7, your uncle offers you a choice, $105,000 in 10 years. So you have to wait. You don't get any money right now, but in 10 years, he'll give you that money. Or he's offering you $47,000 now. You're trying to decide which to do. They give you an interest rate, kind of implying that if you took the money now, you could put it in a 9% account. Which should you choose? The easiest way to do it is put the $105,000 in as a future amount for the number of years you have to wait, 10 years, at the interest rate, and figure out what that's worth today. So the uncle's offer would be like $44,000 today. So you'd be better taking the $47,000 he's offering you today. And if you could trust yourself to stick it in an account, you could leave it there for 10 years. And it would be more than $105,000 if you did it in that way. There's kind of a lot of ifs, ands, and buts in that. One, could you really wait 10 years without touching it? And could you find 9% interest? But those are the assumptions made in that story. So you'd be left with the choice of telling you, the person who's asking you, what should you do? In that case, you should take the $4,700. Okay. So you'll have a few stories that are, which should I do? And then you'll have some that just ask you how much money will be here or how much money should I put in now? That is pretty much Unit 2's homework. A few of these problems may get a little twisted, but honestly, I think it's easier for you to do 90% of your homework and then get back with me and say, or in the discussion board, say, I did okay until I got to problem whatever, and that was just really confusing. You'll have a lot of experience at that point, and we can have a quick 5-minute conversation or discussion on the discussion board and solve your problem. Sound manageable?
Sounds good.
Okay.
Yeah.
I'm going to send you the link to this website for the calculator, the Excel spreadsheet, and put up the video. The videos take a while to download, process, and re-upload to YouTube. So it'll probably be a couple hours before the video's up. Okay? The email should come out to you shortly after the video's loaded. Okay, do you need the website before then?
I wrote it down.
I did too.
Okay. Thanks for joining me, ladies.
Thank you very much. This is
You're
very helpful.
welcome.
Yes, thank you.
Okay. If you need anything, you know how to reach me.
Okay,
Okay.
Thank you.
You're welcome. Good night.
Good
good
night.
night.